In the 1950s, scientists proposed a space station that could house a crew of approximately 80 people. The station could produce artificial gravity by rotating at a speed of W equals the square root of GR, where G is 32 feet per second squared, and R is the radius of the station. If the station design required a rotating speed of approximately 64 feet per second to simulate gravity on Earth, what would the radius need to be? So they've told us that W, the outcome here, is going to be 64, and that G is 32. So we're going to plug in those numbers that we know, and we're going to figure out what R is. So the first thing we want to do is we want to change the square root of 32 times R to a fractional exponent. So we're going to change it from the square root of 32R to 32R to the 1/2 power, because remember that the square root of something is the same as it being taken to the 1/2 power. And then we're going to take 64 and we're going to rewrite that as 8 squared so that we have exponents on both sides. Next, we want to figure out how can we make this square look like this 1/2 power. And to do that, we have to say that it is 84 to the 4th power to the 1/2 power. Now we have 1/2 powers on both sides, and we can look at just the bases, which tells us that 8 to the 4th power has to equal 32R. So all we've done so far is manipulate the exponents around so that we can get something that's easier to work with. 8 to the 4th power is 4,096. Divide both sides by 32. The radius has to be 128 feet. So knowing those rules of the exponents so that you can manipulate the things are going to be very, very helpful. If you need to go back and relook at those laws of exponents, please do so.